Welcome back. I hope everybody had a moment to stand up and stretch. We're having amazing presentations, Jan, and we cannot wait to see what IBM has to bring for us. So our speaker today is Jan. Am I pronouncing that correctly?
Yes, it's Jan, exactly.
Jan, I'm so sorry. Jan Louda. He's a learning enthusiast. He's a design nerd and a technology tourist. Jan's a maker and a non. Jan is a maker and a non-technical enthusiast in technology that works. He's building upon his design practice and has created different educational programs and prepared many workshops and study materials. In IBM, he's responsible for cooperation with universities and high schools in Central and Eastern Europe region. I'm glad you decided to come to the USA for a bit. Apart from the university programs, Jan also acts as a design coach and service designer in different internal and external projects. So, Jan, thank you. It's very difficult for me to get out of my Kentucky country accent and say your name and properly. So, pardon me for that faux pas several times. Thank you for joining us and bringing IBM to us.
Yeah, definitely no need to apologize. You will have to pardon my English because I'm not native speaker, so hopefully you will understand. If there would be any questions, feel free anytime to stop me and ask if something is not quite understandable. So let me try to share the screen. And the presentation as well. So hopefully you see the presentation right now.
We do. Thank you.
Yeah.
Okay, great. So thank you for having me. My name is Jan Louda, as was already said, and I would like to spend some time with you on maybe giving you a little bit under the hood view of what AI actually is and what AI actually isn't, and to uncover some of the AI fundamentals that I think everybody should know to understand how it works. Because there was a lot of things said on the previous sessions, and I especially liked that Lincoln mentioned ethics many times during the presentation, and we'll touch upon this as well. But let me start with a little warm up. So I will ask you if you can spend just 1 or 2 minutes just to go to the site. You can either scan the QR code or type the URL, and just intuitively answer the question: how much AI do you think there is in the different stuff that is mentioned there, like the Tesla car Terminator? It will open up on your phone or on the desktop, whichever you prefer. And I can maybe also paste it in the chat, the link. So let's give it 1 minute to get a few answers, and I see the answers are coming in. So great, thanks for engagement. Yes, and the pattern is similar. So let's actually have a look and see what the answer is. Or how your answer were actually. And it is a similar pattern when I do it with the people on the different presentations. It always gets this similar pattern actually. When talking about advanced AI, usually, you know, the thing like Tesla car, which is perceived as a sort of high-tech car, which has a lot of advanced AI. Definitely, I know I read an article where actually in a Tesla, basically, if you leave the Tesla on a car park in a sunny day and you forgot your pet inside, your dog, the Tesla will, when it gets too hot, automatically pull down the windows a little bit so that the dog sort of doesn't die of the heat. This is something I perceive very cool, very sort of intelligent automation, basically, that there is. So definitely Tesla scores very high. The Terminator movie, from the movie, maybe I am the old guy here, so I know the Terminator movie that was filmed in the 80s. And actually, that's maybe a little bit more surprising. Usually, this comes up as a more to the right as advanced AI, with really something that can perceive, that can think intuitively, that can sort of change voices, it can repair itself, it has emotions and so on. So this would be, for me, maybe a little bit even more in an advanced AI. The Microsoft Excel, even though it scores always on the right side, there is actually quite many AI tools that are already in there. So, for example, if you have this spreadsheet, and on the right side you'll have this analyzed data, and if you hit this, it actually goes to the AI engine and it tries to find the patterns in your data. There is another tool that I discovered recently, that if you have for example, scan an image of an invoice, you can actually use data from the picture to be filled into the Excel and feed it into the different cells, which is again something that is totally AI. As we know it today, it's basically a recognition of the picture, trying to get the information inside. Another one is a flash fill, for example. So if you have anything that you want to fill, any free fields, so for example, you have on one column you have name, on the other you have surname, and then you have a full name. And if you have just want to fill in the full name, you can just hit the flash fill button, and it will recognize what is the pattern of filling the third field, and it will automatically fill in the data. So even Microsoft Excel is basically full of AI nowadays. The computer chess, it's basically one of the milestones that we will see where we sort of celebrated in the 90s. Hey, we are so good at AI that we can beat a human in the chess. Today, I think every lousy phone can beat you in a chess, as the software and hardware sort of are much more powerful today. And of course, Face ID on phones, again, another example of the AI, where you are trying, or the system is trying to recognize yourself in order to unlock the phone, very used on many phones today. So basically, you see that AI, and that's the point why I'm sort of was asking if you perceive that the AI is basically in our daily lives, and the answer is that it actually is. The thing where we get a little bit in trouble is when we try to ask, what exactly is the AI, and what we find out that there is quite a big distortion from the Hollywood side, from the Hollywood movies, because we have, if you just Google the AI, you will get this humanoid with your head full of chips and so on, and but we will probably not see any Terminator coming anytime soon, of course, unless he returns from a far future, of course. But really, it is something that maybe scares a little bit too much the people about the AI and about what would machines be able to do. You have those movies where machines are enslaving people or even outsmarting people in emotions, like in the Ex Machina movie. But would machines become aware of its existence really, if many times they are today, the computers are not even aware that they are connected to the printer at the end of the day? So from my point of view, I wouldn't be like too afraid of the AI as such, as threatening the humanity from this point of view. On the other hand, we will come in with the sort of deception and ethics part, where we see that this actually can be an issue. So where actually, what is AI today? Where can we find it? There are four major fields where you can sort of get across AI. One is called computer vision, which is basically trying to trying computer to learn what is on the picture, try to spot something on the picture, try to annotate the images and so on. This is one part. The second part is natural language processing, which is mostly about chatbots and virtual assistants, basically talking to the computer as if it would be a human and get an answer in a human fashion. Then there is the robotics, which is basically a lot about automation in manufacturing, in the different manufacturing plants and so on. And then there is the maybe data science, which is more a statistical and mathematical approach of the AI. But this again is something that is very common today. If you look at common examples for example, computer vision, we have this radiologist in hospitals. This is a great example where AI helps a lot, because it used to be more that you had a radiologist that looked at the pictures. He studied it. He went from school and started to look at the pictures, trying to spot some diseases, and he got better and better. And then he sort of was the senior one. Everyone was coming to for him to help, and then he retired and died. A new one came, and the wheel started all over again. You know, he was a new one. He made a few mistakes, but he got better and better until he was senior, and then basically he was retired, and then he died. A new one came. With the AI tools, what we have today is that we do not lose this information that we had or gathered in the past. So basically, the newcomers have a great tool that helps them to be a better radiologist in a much faster time. And actually, it also helps the senior ones to spot new basically new for example new diseases as well. So this is from the computer vision. If you look at natural language processing, it's usually the chatbots. We had locally, we had a very popular chatbot, Aneshka, which was during the COVID times, where you could chat with him asking about what is the current regulation, what can we do we have to wear mask, where we have to wear mask, and what is where we can get the shots, and so on and so on. So this was again one of the things which helped a lot during some special cases or special events. Similar is if you are flying, I don't know, to Europe, and suddenly there is a I don't know, there is an volcano eruption in Iceland, and the airplane sort of stops. There is a huge amount of people going to the call centers, and they have all the same questions. You know, what will be my next flight? Will I get some refund? Will I get somewhere some new lodging, some accommodation? And basically, the call centers do not have like another 100 people at hand that they can sort of immediately put online. So this is again a way where you can use technology and automation that can help a lot, and you can switch it on immediately, and it sort of works. Then you have the robotics, especially in the large logistic warehouses, where there are a lot of automation. Not only it is sort of faster a lot of times, but also it is much more safe, because you don't have any in the warehouses. There is a lot of cases where you have injuries of the humans that are the workers that are there. With this, it's not an issue. And last but not least, from the data science point of view, if you look at it, for example, on a Wall Street, it's like 90% of the transactions are done like automated. Only 10% are done by the brokers actually. So, and I think it was a few years back that you could already invest to a fund that was 100% ruled by artificial intelligence. Not sure how was their sort of profitability, but definitely it was something, and that is something that is sort of evolving. And if you move forward, there are much more many cases, either you go navigation or the spam filters that you have on your email, where actually some algorithms, which are basically artificial intelligence, when they see that some Algerian prince is asking for your account because he suddenly wants to deposit $1 million, immediately it is recognized as a spam. Similar is with the Uber pricing model. There is an sort of intelligent algorithm behind. There is a recommendation engines if you are doing shopping. There is also some credit checks if you are sort of asking for a loan. And it's not only in your daily life, it's basically also in a work, where it comes from marketing, where you are doing the clustering of the different segments of the customers, to the radiologists that we were talking about, to the manufacturing, where AI is trying to spot if there is something wrong with the product on the line, so that it can phase it off, so it doesn't go into to the end customers, and so on and so on. Where we sort of get a little bit stuck is when we try to define AI, because there is no one definition that there will be consensus on. This is mainly due to the fact that it is very broad area and quite relatively vague. So you can Google different definitions. IBM is saying that artificial intelligence basically uses the computers and machines to mimic the human mind's ability in trying to solving the problems and making decisions. And you can find different ones on Technopedia or Cambridge Dictionary. From the mathematic and statistic point of view, it is basically about solving complex problems with a big data or large amounts of data. And it has usually two elements. One is autonomy, which means that the user doesn't have to lead the system by hand. It is autonomous. It works by itself. And the second one is adaptability, which is that the artificial intelligence systems should learn and improve as they are sort of performing throughout the time. So this is just in a nutshell where the artificial intelligence is today, and it is basically everywhere. So the question is, why should you probably care? Okay, it is there, it works, so why should I care? There are actually two flavors to this. The first one is, of course, the jobs. And I actually like the one of the sites that you can try to visit yourself. It's called Will Robots Take My Job? And I think it started as a sort of maybe more of a fun page, but now it's evolved into quite a robust page with a lot of data, where you can actually search what would be the job that you would like, for example, to take, or that you are interested in, and you can get some information about how much automation risk there is to this job. But automation risk doesn't actually mean that that it will be totally done by the machines. Automation risk basically is calculated of different attributes of each job, like the originality, thinking creativity, social perceptiveness, the coordination, the persuasion that you need, and so on in this job. And based on these different attributes, they are taking the data from the US labor. So it's very good for the US markets. It can be a little bit different view for the Asian and the European market, but it should be very good for the US market. And you get a calculated risk level of automation. And on top of that, there is also a polling, which is basically what the people are voting and thinking about the how much automation there is, sort of risk of automation there is. And you see that there is quite a large difference between what is calculated and what do people think about, in this case, web developers. They are much more higher of thinking that it will be automated. And I'm not surprised by that, because if you look today, you have this Wix site and the similar sites where you can actually build a web page very easily by just dragging the blocks like a blocks of Lego and building your site. And if you are doing just the simple dragging over, well, why shouldn't some automation do this as well? So basically, this is, I think, behind, especially as we are sort of much more exposed to the generative AI today, and we see what it can do. So this is probably why it scores much higher among the people than what is actually calculated. The question would be, is there any job that sort of I would be safe with? Well, I found, for example, clergy, that is calculated just 0.1%. You know, does it mean that we should all study theology now and going to be employed in a clergy? Would it be something that sort of we would be safe with? Well, as I said, you know, don't take it as as granted what is on this side, because each job is a different. And as you see, even in the church, there is some automation attempts are coming in. Maybe the first one is a little bit funny. I think it's from Germany, where actually they put this sort of blessing robot, more of a marketing, I think, than rather than employing the technology in one of the churches. But for example, there is some in Japan, there are some pepper robots that you can sort of order to lead a funeral ceremony already. So you see that it really depends from the culture. It really depends from the different jobs that you are sort of talking about, how much automation there would be. And meaning that it is automation there, it doesn't mean that there won't be any space for the human tasks. There is this, I think it's like a few weeks old study or survey that IBM has done among the clients. I will share the presentation, and there is a link to this study there as well. And one of the points in the study is that basically 87% of the executives expect that the roles will be augmented by the AI rather than replaced by the generative AI. On the other hand, they say that 40% of their workforce needs to reskill. So basically, impact on the jobs there definitely will be, but it doesn't mean that we all be replaced by the AI and we will have nothing to do but, you know, sit on the couch watching Netflix for the rest of our days. So this is one of the flavors why probably one should take care about AI and trying to understand how it actually works. The second one is resilience against deception. And this is getting more and more sort of visible these days. So let me share with you, I hope you will hear the sound of one of the videos that we have here.
I'm going to show you some magic. It's the real thing. I mean, it's all the real thing.
And you probably recognized Tom Cruise on this video. This was something that gone viral on some TikTok and social media in 2021 as a sort of deep fake Tom Cruise video. Actually, it is this guy on the right side that you see that has leveraged the AI to put, and it's like 2 years ago, put the face of Tom Cruise on his face. And even if you listen to the voice, if you were able or to hear it, you could see that it really sound like Tom Cruise. So basically, this means this was just for fun, but it showed how much sort of powerful this tool can be. And we are not talking nowadays only about, you know, having fun on the social media. Not I think it was like a few weeks ago, 25th of August this year, there was this fake deep fake voice of Polish Prime Minister Morawiecki that was used in a campaign of the opposition. There was a deep fake video where actually in his voice he was saying something that he sort of didn't say, even though it was still a little bit robotic, and it was sort of it was spotted. It is something that we see that is nowadays a common threat. So the question is how not to be sort of deceived, and how to tackle all these job changes and so on. There is probably not one good answer that would sort of satisfy everything or everyone. But what I like is the approach of John Cohn, which is one of the scientists that we have, like the crazy scientists, as I say, in IBM. And he says that the important thing is that will sort of drive you through the future, and the future of technology is the curiosity, critical thinking, responsibility, and play. The curiosity is about finding how the things work, to help you understand what you can expect. The critical thinking is about questioning the argument, finding the other points of view, and making the judgment. And the responsibility is very important, especially with the new AI technologies, is in creating, it is something that is important to the creating part as well as to using the technology. And it has a lot to do with the ethics that we will touch as well. And the last but not least is the play. Is like embrace the new technology really as a new toys. And as it was with this previous speaker, try to play with, try to see what it can do. And if you understand what it can do, then it probably will be much more resilient to any news that can be sort of twisted or faked, and that will be sort of out on the internet, sort of trying to trick you. So what I like is something that was put on AI, OpenAI, I think half a year ago, as a quote, that AI will not replace you, but the people who know how to use it will. So this is probably the message. So this is why we should sort of take care about what the AI is. And let's do a little bit expedition into the AI a little bit more deeply, but without going really into being too technical. Let's look at some of the milestones. The AI, from the Adobe, we heard, that the speaker was playing with the tools for 10 years, where they had this AI in it. Actually, it goes back to the 50s, where it was coined as a term in the New Hampshire in a conference of MIT. And it sort of rocketed with in the 60s, where there was a little different games that were able to beat people. It started with the checkers, hey, we were able to beat people in the checkers. So basically, we will soon have artificial intelligence overwhelming the world. It was the similar as we sort of hear today with the OpenAI and GPT. But then it came the 70s, which is sometimes called AI winter, because in the 70s we had this financial crisis and the oil crisis. So there was a little bit less money going to the research. Also, the algorithms that were sort of on a paper and a theory were not able to be run on the hardware that was available at the time. So basically, the AI was a little bit developing very, very slowly. But it sort of kicked out or kicked forward in the 90s, where we had something like a cloud coming in. We had a broadband internet available, and suddenly, the stuff that was not able to be calculated easily on the machines in the 60s and 70s were suddenly sort of much more accessible. And if you look at the milestones, it was like 1997, where the first we managed to, the computer managed to beat the Garry Kasparov, which was the world champion in chess. In 2011, we have a computer winning over people in Jeopardy. In 2016, we were having the people beaten in Go game, which is much more sort of difficult regarding the different possibilities than chess. Then we have in 2017, we have the Texas Hold'em poker, where actually the computer has beaten the champions in poker. And again, we have a little bit difficult game where you are playing with not all the information and so on. In 2019, we had a project debater where we had the people that were sort of beaten by computer in debating and arguing on a selected topic. And on 2022, we had the GPT coming in, which was really a revolution, and we see that the uptake, like in 3 months, was like total wow to everyone. And nowadays, you see that the Chat GPT or the foundation generative models are implemented almost everywhere. Everywhere you look, if you look at Canva, if you look at the different tools, you see that there is some AI prompting that is already there. But the AI is not only about the technology and about the games. It has many different flavors. And this means that you can actually get engaged in the AI and do an AI related job, even in the different fields. One of them is, for example, philosophy. And since we have very little time, let's just touch it very briefly. In philosophy, even in the 50s, we had something coming up that is called Turing test. Basically, it was by a computer scientist, Alan Turing, and he tried to answer the question, how can we tell that the machine is intelligent? And what he did is that he defined this test that you have the human evaluator who is texting with, and he doesn't know if he is texting with a machine or human. And if he cannot decide or cannot guess if it is a machine or human, then Turing says that then the machine basically fooled him and the machine can be perceived as intelligent. And the Turing test, even it is from the 50s, it is used a lot even nowadays. There are this Marcus test where they let the computer sit and watch the TV show, and then they try to, by asking questions, to see what was the understanding of the computer of what was happening in the TV show. There is this Lebner Prize where the computer is having a 25-minute conversation with the jury, and the jury then sort of tries to decide if it is sort of perceived as an intelligent. Maybe question to the audience. You can raise your hand. If have you ever been in these tests? Any of you? No hands up. Nobody took part in this Turing test. Well, actually, I think we all are taking part in this test, or in a different flavor of the test. This is called reverse Turing test, and this is this CAPTCHA. So CAPTCHA basically means completely automated public Turing test to tell computers and humans apart. So every time we have this annoying, annoying fields where we try to guess if this field has the part of the bus or not, and we are trying to get us through to the page. This is basically a Turing test in practice. Nowadays, a lot of time they are using reCAPTCHA, where you just have to check the box. So you are saying, hey, what, computer cannot check the box? Well, the computer can check the box very easily as well. But what they are doing is they are trying to analyze how is your movement of your mouse towards the checkbox. Because if you are a computer, you will have a uniform movement in a line to the checkbox, and then you click the checkbox. Whereas if you are human, you are basically trying, to find where is the right space, to click, and you don't have this uniformity, which sort of translates to the Google or to anyone who is using it. You are not a robot. We can let you in. But staying still in the philosophy field, in the 80s, there was this American philosopher, John Searle, who sort of tried to attack basically the Turing test experiment with something that is called the Chinese room argument. So Turing test and Chinese room experiment are one of the two key philosophical approaches that you will probably come across when talking about AI. And this is really a thought experiment that tries to show that the ability to answer the questions in a meaningful way is not enough to demonstrate that you have the ability actually to understand and ability to think, which is what we expect from the something that is called a strong AI. And in this experiment, we sort of imagined that there was this human who is in a box or in a room, basically, and he doesn't speak Chinese, and that's but he has all the dictionary of all the different possible sentences and all the different possible answers to all the questions in Chinese that there is, and he has a rule book how to answer these. And if someone from the outside just inputs a question in Chinese, he basically, based on the rules, can find what is the answer and output the answer to the person who is asking. And the person who is asking can have the sort of perception that the person inside knows Chinese very well. But the truth is that basically inside the room, the person inside the room doesn't have any knowledge of the Chinese. So basically, it is something that can be done by a stupid machine. It can be done by a monkey. It is not showing any intelligence, what John Searle says. And basically, based on this, or from this moment, from the 80s, what we come across sometimes is you will find something is weak AI and something is strong AI. And basically all that we hear today and all that we have seen today from the Microsoft, from IBM, from Adobe, this is actually a weak AI. It is ability that we program the machine, that its actions are indistinguishable from the humans. But the strong AI is not here yet. And in my opinion, it will be maybe a few decades, maybe more, when we'll see strong AI. That would be probably the Terminator. You know, the computational model of the all human reasoning and all the mental states. So you see that you can engage even in philosophy. Another thing where you can engage with the AI is AI ethics. One of the most popular one was the moral machine. Moral machine was an experiment designed by the MIT, and it got very viral soon. And actually, they managed to gather over 40 million decisions in a different countries, in over 200 countries all around the world. And the moral machine experiment was just that you had a self-driving car, and you always had to decide what the car should do in a critical situation. So, for example, on this example, should it go straight, or where it will be killing maybe more elderly people, or should it sort of steer away, but it will be killing like a young family with 2 children. And this sort of from my perspective, very hard Sophia choice, horrific questions were sort of answered, and basically it's still on, and you can still try this experiment yourself. And based on the data they have sort of gathered, they managed to sort of cluster it into 3 what they call the 3 like civilization, or 3 perceptions. One is the Western, one is the Southern, and one is the Eastern. And they, as you see, they differ quite a lot. The US is in a Western civilization. The Czech Republic, I think we are Czechia here, we are in the Southern one. So and you see that there are many differences. It is probably not readable, but you know, on the axis where they differ, the Southern and the Eastern is, for example, sparing the young, where in the Southern culture we are more towards sparing the young, apart from the elderly. On the Eastern culture, like Japan and China and so on, it is more about sparing the elderly rather than sparing the young. So you see that there are very many differences, and this has implication when you are sort of building, you know. So imagine that you are sort of buying a self-driving car in Japan, and then you want to drive it in Europe. How will it behave? Well, will it behave like in Southern model because you are driving from Europe, or will it be Eastern model, or will it like change the firmware once it crosses the borderline? What are these questions that are sort of coming up? So actually, the ethics itself is one of the large field that is as we have seen on a sort of top priority by the major players like Microsoft and also IBM. And IBM has defined these 5 pillars of AI ethics that every new system sort of should play by. It's the explainability, fairness, robustness, transparency, and privacy. Explainability is about that you have to be able to explain why the AI got to this answer. So if the AI says, "Hey, I will not give you the loan in a bank," why? You as a customer should know why. So there should be some explainability behind the model. The fairness is all about the bias that we see today that in many of the systems. Robustness is being it secure, that you can sort of cannot trick it from outside. Transparency and privacy is about that the user knows what the system does and that the data are kept private and the consumer data is protected, and basically the data belongs to the creator. If we just have a short look on, for example, the security and robustness, this is a way how you can fool a neural network, basically artificial intelligence. From a human perspective, from a human eye, you don't see a difference between the first and the last picture. It's all basically a panda. But if you put it through some neural network, on the first picture, the neural network says, "Hey, I think 57%, 58% that confidence that is a panda." And if you overlay like this noise picture in the middle, just over the panda with the 0.007 transparency, we still do not see any difference as a human eye. Suddenly, the neural network will give you the result that it is 93% confident that it's a gibbon. So this is something that's called adversarial attack, and this is one of the things that the AI solutions are trying to be sort of robust against, so that it will sort of withstand. And if we move from the other fields, there was the philosophy and ethics. We can go more to the computer science, where you should be sort of aware of the different terms that you come across when talking about artificial intelligence. Sometimes you hear the machine learning, sometimes you will hear something that it's a deep learning model, sometimes you will hear about generative AI and foundation model. So what are actually those? These are not quite interchangeable. These are more like nested together, like these Russian dolls are nested together, where the machine learning is basically about trying to uncover some patterns in the data, and then trying to apply these patterns, these inputs through the patterns to generate the corresponding outputs. The deep learning is more about neural networks, which are basically an interconnected different nodes, like a network of nodes, which are processing the information. And they are suited like when you are trying to recognize something on the image, or when you are doing the speech recognition. So this is where it is used. And lastly, and basically lately as well, it is the foundation model, the generative AI, where it's actually some specific kind, again, a nested part of the deep learning, where you have the special neural network, which generates the sequences of related data elements. So basically, it is trying to predict the next best word in the sentence. It is trying to predict what would be the next best pixel in this image. And by this, he's sort of step-by-step generating the answer, like ChatGPT, or the image as a Bing image creator, and so on. So this is basically the terms that you will sort of come across. If you look at a machine learning, how it works is different how it works in a classical programming. In a classical programming, it is basically a rule-based system. You are programming a series of instructions. You are saying, if you are having a triangle has 3 sides. And this is the rule by which you will decide that it is a triangle. In a machine learning systems and in AI, it is more about training rather than programming, which means you are throwing bunch of data, and it can be sort of millions of data. It can be text, it can be images, like millions of triangles saying, or hundreds of triangles saying, all these are triangles. And the system itself basically defines the rules and creates the rules how to recognize that it is a triangle. So this is the main difference between how the classical programming, whereas the machine learning approach works. When we will be talking about machine learning, you will sometimes come across that they will say, hey, this one is done by supervised learning, and this one is unsupervised teaching or learning, and this is the reinforcement learning. So what are these machine learning types? Basically, supervised learning means that you are feeding it with examples. So, for example, you are feeding images of pictures of a cancer and saying this is a cancer. So train yourself to spot a cancer on this picture. Whereas, and then you feed in any new data that the system hasn't seen before, and he's trying to classify it if, hey, I can see it, I can see the cancer in this picture, or no, this is the cancer-free picture. Whereas the unsupervised learning is more about that you are just throwing the data and you are not giving it the right examples of what it is. And you are just, saying, just, try to do something with the data. And it is usually used for the clustering. So for example, in this picture, a lot of Disney characters, and it would probably cluster the Donald the duck and all these ducks because they are ducks and they have beaks. Whereas the other ones will not have. So they are doing the clustering. This is used, for example, in marketing where they're doing the clusters of the customers. Or it is used on yourself if you are using Spotify and you have these recommendation engines. What they are doing is basically they are clustering you. You are a cluster of these type of consumers in Spotify that like this type of music. And we know that you are sort of listening to the rock music. So we will do a recommendation based on this because you are in this cluster. So if you are listening all the time to the rock music, it is not very probable that the Spotify will recommend, hey, have a go and listen to Bach. It probably won't, because it tries to recommend you something that it thinks you will like. And then we have the reinforcement learning, which is used a lot of times in the games, but also in the, for example, advertisement recommendation as well, where it actually teaches based on the environment. So basically, based on the action that you make, the system gets sort of rewards and observes if it's doing well or not, and refines for the next round. So these are the three types of machine learning that you can come across. So just to understand it, what is the machine learning doing? If you look at what it is doing, it is basically three tasks. Either it sort of predicts a number. So for example, regression is about predict me what is the price of the house in this locality where we have this services nearby, where there is this pollution score, etc. And it tries to predict the number. The second task it does is the classification. For example, the spam filters. Try to classify if this email is a spam or is not spam. And then it does the clustering, as we mentioned, for example, in a Spotify. But for sometimes, or for some tasks, like natural language processing or image processing, this was not quite easy. And there comes the neural networks, which are basically something that is a set of algorithm that is sort of loosely modeled after what we have in our heads. So they are not trying to do a digital brain. They are just trying to do a mathematical model of a neuron, which has some inputs, does something. So he processes this information and outputs it. And they put these neurons in a different layers, and imagine that the blue layer, there can be like thousands of these layers, and each layer can have thousands of nodes, and you just pass the information through all the network to get get the answer. So this is how the neural networks work. And this is where actually there comes an issue. When you put something in a neural network, it bubbles through the network, it gives you an output, and you ask why. And usually the people, the IT guys, they was designing the neural network, say, well, we cannot tell really. It's hard to tell, because it's a little bit of a black box. there are a lot of weights, a lot of parameters. And we have seen it when from the ChatGPT, basically the GPT foundation model came to the Bing, that it didn't give you the exactly same data, because they sort of changed the parameters, and they sort of played at it, and they tune it all the time. You know, it's something that was possible to ask a few weeks, months ago, is not possible to be asked today, because there is some bias, and they try to repair it. They try to sort of make it straight. So these are the neural networks, another term that you will come across. You don't have to understand it, just to know that neural networks are something that it does, that it belongs to the AI. And the most important and the most recent one is the generative models. And the generative models, that's all these GPTs and so on, they predict and try to generate the sequences of related data. So they have been fed unlabeled text data to some machine algorithm, and they have created this model, this great big foundation model, where you sort of ask something with the prompt, and the foundation model tries to, I don't want to say guess, but predict what would be the sequence of the data that will have the greatest confidence. You know, that would what would be the next word in this sentence, what would be the next pixel in this picture. And we have seen that if we want to say what can be generated, actually you can generate images and photos. If you go to Midjourney or DALL-E or Bing Image Creator, you can do very good photos and images that you can sort of use in your presentation, for example. There are new tools where you can even do videos and animations like Synthesia, DBrain, Video, and so on. You can even do sounds and music, as we have seen with Adobe, and there are many other tools like EvenLabs, SoundDraw, where you can actually even model the different voices from. They are even open source on the web. If I want to speak in an Indian accent or German accent or the Czech accent, I can sort of select it, and it can sort of create the voice based on some learning it has done, because it has some data on how the Czech people speak English, and based on this, it will create basically these waveforms, wave files that we listen to. And then it is the text and code like ChatGPT, Bard from the Google, or the Bing Chat from Microsoft that we have seen. As an example, if you put a prompt to the DALL-E, like create a fantasy style illustration of young blonde girl in an ocean with a beast in a storm, this is basically what the DALL-E gave me. On the same prompt, this is what the Microsoft Bing has created. And with a very similar prompt, this is what Midjourney has created. All, I think, are very good illustration, even from some fantasy book. I wouldn't be offended if this would be on a cover or something like this. And it is not only images, it's also the text and code. So if you come across the different examples that are very common on the internet, for example, especially the programming task, there are these sites where you can sort of try to solve the different coding puzzles, like LeetCode, or there's a site called Code Wars. And basically, if you put this in a ChatGPT, you would be spending maybe like 20 minutes to solve it and to write the code, maybe 30 minutes. The ChatGPT gives it in 1 minute. It gives it together with the explanation, and it is correct. What you have to do is, on the other hand, you have to check that it is correct. You can try it yourself. You know, I've tried myself several times. For example, try to write an essay on Paleolithic period in some place in the Czech Republic, because my daughter had this task. So I said, hey, let's try what the ChatGPT would do, and it did quite well. Like, it did perfectly for 99%, but the 1% was like totally off, where he said that this is something most important in the Middle Age. You know, from the Paleolithic, we suddenly moved to the Middle Ages. You know, so you have to really be very careful of what it brings. But nevertheless, as I said, it is a big revolution. And why it is a big revolution? Because in conventional AI, what we did is that we tried to solve the task by having this training data and hundreds of thousands labeled data points. And labeled data points mean that a human has to label these data points. So it's a lot of sort of low value added task that you have to do, human task, to have this data just to perform, just to build a model that will perform one task. You had another task, you did the same, another 100,000 labeled data. With the generative model, what we have is these foundation models, which are common. So basically, you have this one big, huge foundation model with a million of parameters, and you can do something that's called zero-shot prompting, where you just ask it a question and it gives you some answer. But what you can do as well is something called few-shot prompting, where you do several questions and you give them handcrafted examples, which sort of narrows down the foundation model, and also it allows it to answer questions that it wouldn't answer before. And you can go even further, and you can do something that's called data-driven tuning. So you have a labeled tuning data that you can put on top of the foundation model so that it precisely answers correctly what you want. And the beauty is that you don't have to have hundred thousands of these labeled data points, because you don't have to train all the generative foundation model that is already trained. You just need maybe hundreds or thousands labeled data. And then the foundation model would be able to answer the question like, what is the vacation policy of IBM in the Czech Republic? If I ask that ChatGPT, he would know, because it is on the intranet, he doesn't have access to this data. But if I use the label tuning data, it can be something that he suddenly knows the answer to, and basically it is something that can be used very well in a business. And this is where we get to what IBM is doing in this field. What we have come with is a framework. It's called Watson X. It was announced in the late July, I think, this year, maybe beginning of August. And basically what we're saying, it has three important parts. It's a platform to build the solutions. It's not the end user solution. And the platform has three parts. First is something like, imagine a studio, something where you can sort of train and create your models. You can deploy the models. There is this prompt laboratory where you can try your prompt if they work or not. And you can change the different foundation models, because GPT 3.5 or GPT-4 is not the only foundation model we have. There is a Llama foundation model that is developed by the Facebook. There are others from IBM and from other ones. So you can bring your own foundation model as well. Then the second part is data, which is important one, where actually you can have these workloads, this curated data. You can share it, you can store it, and you can have a data that is basically trusted, that you can build a solution with. And last but not least is basically a governance, where when you are building a solution, you need to have some life cycle of the solution that you can take care of. So something that you can something that you can manage as a sort of large enterprise. So this is why we have the Watson X, and where there is a platform. If you are more into the IT, there is a trial that you can try. If you just Google Watson X, it gives you to the page. If you are not up to the Watson X as a developer yet, but you say, hey, the AI is a very interesting topic and I want to know more, what I recommend is go to the IBM Skills Build platform. This is open platform that you have available, and if you log in either with your Google account, LinkedIn account, or just with your email, you have access to many different free e-learning resources. Some of them are also ending up with badges that you can put on your LinkedIn profile. So, for example, artificial intelligence, fundamentals, building trustworthy solutions, and so on. So these I sort of poke you a little bit, try to get some badges, and try to maybe understand even a little bit more about what AI is. And for those that are just playful, on the last slide you will have, once I share the slides, you have something you can try for fun. Either you can play tic-tac-toe with the AI and see how the AI gets better and better over time. You can try if you can spot which photograph is real and which one is fake. Or you can try your prompting skills with the train your prompting skills, where you have basically an AI and you try to trick it to give you the password. And with every level, the AI gets better and better, and you are trying to trick it. So that's my sort of introduction to the AI, so that you understand maybe a little bit what's behind, and you are aware what the AI is and what it can and what it cannot do. And thank you for your attention. And if you have any questions, I know that I fully use the time, but I will stay here and try to answer any questions that that there are in the chat.
Jan, thank you so much. So much information, and I love how you broke down the definitions for us. I think that's really beneficial for lay people who aren't in the tech field. It's beneficial for me to get the clarifications on those terms and all that IBM is doing. I can't wait to learn more and get more micro credentials. For everybody who's online and U of L's Digital Transformation Center Learn page, you can access all of the IBM products that Jan was just talking about through there, the ones that are public right now. So thank you very much. We so appreciate IBM being here. And you queued us up really well for LinkedIn coming up next in your comments.